Imagine a world where one man's courage to question the sky changed everything. Galileo Galilei, born in 1564, was not just a scientist. He was a force that pushed humanity out of the darkness. He polished lenses, pointed his telescope at the heavens, and suddenly the universe looked different. Mountains on the moon, moons circling Jupiter, stars no longer fixed in place. He saw things no one had dared to imagine, and for the first time in history, humans could prove that Earth was not the silent center of creation. But imagine if his discoveries were rejected completely, not just challenged, but erased from thought, dismissed as madness, and locked away forever. Before we step into that alternate world, consider how much of your daily life depends on the idea that the Earth moves, that planets orbit, that the universe follows laws instead of superstition. Now imagine waking up in a timeline where those truths never became truths at all. This is the world we are about to enter, and if you find yourself pulled in by this journey, make sure you subscribe so you don't miss the stories coming next. In our real history, Galileo's work cracked open a door that others rushed through. Newton, later Einstein, and eventually every modern scientist stood on foundations he helped build. But suppose that door had slammed shut the moment he tried to open it. In this alternate timeline, the powerful institutions of his day do more than silence him. They erase him. His telescope is forbidden, his notes confiscated, his students pressured to abandon him. The idea that Earth orbits the sun becomes so dangerous that even whispering it is enough to ruin a family. And just like that, the truth is buried. When truth is buried, curiosity soon follows. Without Galileo's evidence, early scientists stay trapped in old beliefs. The night sky remains a mysterious painted dome instead of a doorway to discovery. Children grow up being taught that questioning the heavens is not just improper, but dangerous. The few who feel the urge to ask more keep their questions to themselves. They learn that silence is safer than truth. Across Europe, the atmosphere begins to shift. The scientific revolution no longer feels like a revolution at all. Progress slows to a crawl. Discoveries that would have appeared in the 1600s get delayed by centuries. The spark that should have lit the modern age flickers, struggling to survive. Without Galileo's proof that heavenly bodies move with predictable rules, early mathematicians failed to build the equations that define gravity. Future inventors have nothing solid to stand on. By the time the 1700s arrive, a strange stillness covers the intellectual world. Telescopes remain rare and astronomy becomes a discipline of tradition instead of exploration. Universities continue teaching Earth-centered models not because they make sense, but because no one dares to challenge them. The dangerous idea that the universe might be bigger, older, and more dynamic never gets the chance to bloom. This doesn't just affect scientists. Ordinary people grow up with smaller dreams. When the sky above you feels fixed, eternal, and unchanging, you never imagine reaching for it. There is no concept of space exploration, no whispers of distant planets, no curiosity about what lies beyond. The sense of wonder that drives human ambition fades little by little. Progress slows in ways no one can measure, because no one remembers what could have been. Meanwhile, on the other side of the world, the young United States struggles in unexpected ways. Without the influence of European science advancing rapidly in the 17th and 18th centuries, American thinkers inherit a weaker foundation. The scientific ideas that shaped early American innovation arrive diluted, incomplete, or missing entirely. A culture that once prized discovery becomes hesitant, guided by old-world caution instead of bold exploration. As the Industrial Revolution approaches, something feels off. Machines progress more slowly. Navigation across the oceans remains dangerously imprecise. Factories struggle to measure and predict forces they don't fully understand. Even timekeeping lags behind, because without precise astronomy, clocks remain unreliable. Every industry feels the weight of what was lost when Galileo was silenced. But this timeline is still young, and the world is about to feel much bigger consequences that shape nations, wars, inventions, and the very future of humanity. As the 19th century unfolds, the world senses that something is missing. Humanity feels ready to advance, yet every breakthrough seems to take twice as long and cost twice as much. Without Galileo's foundations, scientists are forced to rediscover truths the hard way, like climbing a mountain without a trail. Many abandon the journey halfway, and those who persist are treated as dreamers chasing illusions. The idea that the Earth moves, that planets orbit, that the universe follows elegant and predictable laws remains buried under layers of tradition and fear. By the time electricity begins shaping the modern world, a darker consequence emerges. Nations realize that their scientific progress rests on uncertainty. Without solid astronomical knowledge, navigation systems fail frequently. Expeditions vanish at sea, simply because sailors cannot trust their instruments. Global trade grows slower instead of faster. A world that should have been tightly connected by the late 1800s remains scattered and cautious, afraid to push the boundaries of the unknown. In the United States, this hesitation becomes a defining cultural trait. America still grows, still innovates, but its progress lacks the spark of confidence that comes from centuries of scientific clarity. Factories operate with less precision. Engineers design machines with wider margins of error because the fundamental laws beneath their work feel unstable. Every invention feels like a gamble rather than a step towards something greater. And without accurate astronomical data, the country struggles to coordinate long-distance communication and railroads with the efficiency seen in our timeline. This uncertainty shapes politics as well. In a world where the universe is still a mystery, leaders hesitate to invest in the far future. Scientific research receives less funding. Exploration feels unnecessary, even foolish. Why build observatories when the heavens are believed to operate under divine rules rather than physical ones? Why push for space when no one is even sure what space truly is? America grows, but with a quieter, heavier spirit, as if carrying the weight of invisible chains. The 20th century arrives like a storm, but instead of being prepared, humanity is standing in the rain without shelter. When world wars erupt, technology is far behind. Nations fight with older machines, slower communication, and poorly calculated strategies. Weather prediction remains primitive, costing thousands of lives at sea. Even aviation, which in our world transformed warfare and transportation, develops much later and with far more accidents. Engineers simply lack the mathematical certainty needed to master the sky. By the 1950s, a strange irony emerges. The more humanity advances in some areas, the more painfully obvious its limitations become. People look at the stars with the same wonder Galileo once felt, but without his telescope proving that the universe is full of motion, possibility, and change. Children grow up hearing myths instead of science. Adults accept mystery instead of answers. The curiosity that once drove entire generations begins to fade into something quieter, resignation, and then something remarkable happens. A small group of independent thinkers, scattered across Europe and America, rediscovers the sky through forbidden lenses. They build telescopes in secret. They share notes in coded letters. They risk their careers and reputations because they believe what Galileo once believed. That truth is not determined by authority but by evidence. For the first time in centuries, someone points a telescope at Jupiter and sees its moons dance around it. The revelation spreads quietly at first, then uncontrollably. Students talk, professors whisper. Amateur astronomers challenge established institutions. And slowly, the old model of the universe begins to crack. But this time, the shift is not smooth or celebrated. It creates a cultural earthquake. Entire societies struggle to accept that everything they were taught was incomplete or simply wrong. People feel betrayed by centuries of certainty. Governments panic. Religious leaders argue. And yet the truth keeps spreading, because once the universe reveals itself, there's no covering it again. For America, this becomes a turning point. The nation realizes it has lost centuries of progress, and for the first time, it moves with a sense of urgency. Universities expand their research programs. Innovators push for rapid modernization. Young people grow hungry for discovery, determined to catch up with the potential their world should have achieved long ago. The country throws itself into scientific exploration like a runner trying to close a gap in the final stretch of a race. But the delay has consequences. The space race, which in our timeline defined a generation, begins decades late. The moon remains untouched. Satellites are still a dream. And the global power balance shifts dramatically because nations that should have been scientific leaders find themselves decades behind where they could have been. This alternate world becomes a haunting reminder that progress is not guaranteed. Acceptance of truth can move humanity forward, but the rejection of truth can freeze it in place for lifetimes. And yet, as this world slowly crawls toward a delayed future, one question rises above everything else. What would our own universe look like if curiosity had been protected instead of punished? If ideas had been welcomed instead of silenced? If humanity had followed the path Galileo tried to light centuries earlier? If you want more stories like this, make sure you subscribe, because we're just getting started.